blank. We want to come back to this, and the reason I skipped it right off the bat was because this is not in the form that the other ones were. This is in that function form that we worked with in T-charts. We have the y on one side, the x, and everything else on the other. So I want to get my x and y on the same side if I'm using the intercept method. So what I would recommend if you come across a problem like this is just get your x on the same side as the y. So I'm going to add 2x to both sides. Negative 2x plus 2x is 0. So all I have left over there is negative 8. And over here, these aren't like terms, so I'm just left with 2x plus y equal to negative 8. Not that much work, and now I'm ready to go ahead and solve for my values. Doesn't matter what I cover up first. I will cover up the y just to follow the same pattern we've been doing. I get 2x is equal to negative 8. That means my x is negative 4. Divide both sides by 2, which would be the point negative 4, 0. Now I'm going to go ahead and solve for what my y will be. I have positive y equals negative 8. Not too much solving needed there. Y equals negative 8. So this point, 0, negative 8. I go down to graph it. Now I notice that the 4 would be okay, but when I do negative 8, I'm going to be off the chart. So I'm going to count, in this case, by 2's. And like I said on the other lesson, if you're counting by 2's, please label it so that I know that that's what you're doing. Negative 2, negative 4, negative 6, negative 8. This way, when I look at your work, I don't say, oh, they messed up. I can say, oh yeah, they did it right. They counted by 2, so everything's perfect. Negative 2, negative 4, 0 would be right here on the x-axis, our x-intercept. 0, negative 8 is down here on the y. And I totally missed the mark, but on the little pen I'm using, it's a little difficult. And we see that that's our line, okay? Voila. Excellent job, guys. All right, one page more to go over. And this is where it all comes together. In example 2, we're going to look at a word problem and set up an equation. It says, you're canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip, and give 3 possible paddling and drifting times. Okay, so this is like a real-life example of where an equation could come into handy. Whether you'd use it or not, it's a different story in this situation, but we're going to see how we can use an equation to model a real-life situation. So we want to identify a few key things they tell us. They're telling us that we are using 12-mile stretch of river to cover in our canoe. So we're covering a 12-mile stretch of river total distance. We know that when we go paddling in our canoe, we go 4 miles an hour. And when we just drift, it's 2 miles an hour. And I'll just add drifting in there. It's on that next line. Okay, so 2 miles an hour when we drift. Those are the 3 key things they gave us. So the first thing we have to do is write an equation. Now, what I would recommend is figure out what your total is. You see that you're covering 12 miles. Usually the total goes after the equal sign, and it's going to be the same here. If we know we're traveling 12 miles, put that equals 12. Now the next thing is we have these words per. Usually when you see the words per, that indicates a rate of some kind. Comparison of 2 different values, 2 quantities, and we have 2 variables we're working with, don't we? We have 2 pers and we have 2 variables, so that works. So what we're going to do is we're going to separate them. We're going to say, we're going to use our variables x and y, and we're going to label them. This one says we go 4 miles per hour when paddling, so x is going to stand for how many hours we paddle, our hours of paddling. And then the next one says we go 2 miles per hour when we drift. So y is going to stand for the number of hours that we go drifting. Okay, so since we said these indicate our variables, this 4 miles per hour when paddling can be modeled by 4x. 4 miles per hour for every hour that we paddle. That's what x stood for. 2 miles per hour when drifting can be modeled by 2y, because we're going to go 2 miles per hour, so 2 miles per every hour, and that's what y stands for when we drift. If we add these 2 together, we get our total of 12 miles. Okay, so congratulations, you have just written your first equation. Alrighty, so x-intercept, we need to figure that out. We can cover up this y value. Just pretend that y is covered. Oops, if I pull out and actually cover it, I get 4x is equal to 12, divide by 4, divide by 4, x equals 3. So my point is 3, 0. Then, if I go ahead and I cover up the x to get my y value, then I see positive 2y is equal to 12, divide by 2, divide by 2, y is equal to 6. So this is going to be 0, 6. Let's plot it because it says write in graph an equation. So we're going to plot these points, 3, 0, 0, 6. Connect them with as straight of a line as you are able. Okay, this is our y and our x-axis. And there we have just graphed this equation. So we've done the graphing, we've done the equation writing. The last thing they want us to do, we've modeled this real-life situation with an equation and a graph. Now we want to display that and give 3 examples of possible paddling and drifting times. So any point on this line represents a combination of paddling, which was our x value, and drifting, which was our y value, possible combinations of times. So the easiest thing is we know that this point is 3, 0. We know that this point up here is 0, 6. Now, I don't really know what this point right here is. It's like in the middle of a block. Same here. I know that that's a 1, but I don't know what the x is. This point, though, I know is 2, 2. Because I did this with a straight line, and it actually comes to cross right there. This point, I believe, also crosses if we were to use a straight ruler, which would be 1, 4. So any of these points that we know exactly, they're crossing right where the grid lines overlap, we know exactly what those ordered pairs are, and that's going to give us some information. Here's the information it tells us. The point 0, 6. 0 is our x is paddling, so that means 0 hours paddling, and then it means 6 hours of drifting. So if we plan to just drift the whole day, it's going to take us 6 hours to get there. The next point that we have is 1, 4, which stands for 1 hour, oopsies, we don't want parentheses, stands for 1 hour of paddling, and then 4 hours of drifting. So 5 hours if we plan on just doing a little bit of work. And we could keep going with this. 2, 2 is going to be 2 hours of paddling, 2 hours of paddling, and then 2 hours of drifting. So that's another combination we could follow. And then the last option we had was 3, 0. And this ordered pair stands for the option of 3 hours of paddling, so paddling the entire time, 0 hours of drifting, and that means we will get our 12-mile span covered in a total of 3 hours. So a whole bunch of different possibilities, plus all of these points in here will work as well, but like we said, without a calculator that does graphing, we don't know their exact values, so they're not as easy to determine. So pick a point where the lines intersect.